Hello, lovely geometry students. Welcome to lesson 1.18, Evidence, Angles, and Proofs. Today, our learning target is I can label and make conjectures from diagrams. I can prove vertical angles are congruent. So this is a new concept, and vertical angles make an X sign, okay? And they are opposite angles. Could be those or the other two. All right. Our competency is to justify, and let's get this party started. Try out the do now. Mentally evaluate all of the missing angle measures in each figure. So you might remember from middle school that two angles that make up a straight line, this angle and this 50-degree angle, equals 180 degrees. They're supplementary. We're going to write that later. So pause this video and try to figure out what the missing angle is where there's no number. All right. So mentally, you could think that what plus 50 equals 180 degrees? You could say 130 degrees. You basically do 180 minus 50 to get 130. What's 180? Figure F, figure C on the right. 180 minus 65 degrees is 115 degrees. And let's look at figure B. So we know that if this angle is 30 degrees, those rays open up to 30 degrees. If we focus on this straight line, we know that angle HEG is 150. And if I look at the supplementary angles this way, if this is 50 degrees, 150 plus 30 degrees equals 180 again. And if I go all the way around, I get 150 again. 30 plus 150 degrees is 180. What do you notice about any patterns? You might have said that the opposite angles are congruent. Okay, so that's a special property of vertical angles. Last but not least, we have figure D, and we have, I like to trace the straight line that makes the two supplementary angles. And 180 minus 135 is 45 degrees. And I know that opposite angles, when it makes a X, vertical angles are congruent, and we have 45 degrees here. We could also test this theory. These two angles add up to 180. All right. So supplementary angles are 180 degrees. You could see a straight line, and angles that add up to that straight line are 180. Vertex of angles is, I like to call it the elbow. Let's put arrow at the ends on these rays and label that vertex. Basically means corner of an angle. Pause this video if you need more time. Let's move on. Explore number 1. That can't be right, can it? So let's jump down to the student task statement. Here's a figure where ray R meets ray L. So don't forget, in geometry, it's usually just describing the figure. The dashed rays are angle bisectors. So this angle is cut in half by this dashed line, and this angle is also cut in half by this dashed line. John made the conjecture. The angle formed between the angle bisectors is always a right angle, no matter what the angle between R and L is. It is difficult to tell specifically which angles John is talking about in his conjecture. Label the diagram and rephrase John's conjecture more precisely using your labels. So let's check it out. First, we're going to label the diagram, and I'm going to just use the alphabet A, B. I'm going to just use C, D, and then E, F are the bisectors. Why did I switch up the orders? I don't know. The only time the order matters in a quadrilateral. All right. So I'm going to read this conjecture again because it's kind of confusing. The angle formed between the angle bisectors is always a right angle, no matter what the angle is between these lines, L and R, that's made. It's difficult to tell specifically which angles John is talking about. Okay, so then we labeled. So I know from our do now that there's a supplementary angles here, two angles that add up to 180. So I'm going to use this angle, and we say angle ABC. We're going to practice with notation today, plus angle, this angle CBD. And notice that the second letter is always the vertex where the angle is equal to 180. And let's take the angle formed between, I'm going to read it again. The angle formed between the angle bisectors is always a right angle. So something has to equal 90 degrees. So if we take half of angle ABC and I add it to half of angle CBF, it's going to equal a right angle. Is this conjecture true? Explain your reasoning. So you can look at the images above. Whenever you have two lines that make up a supplementary angle and each angle is bisected by the dotted line, it always equals a right angle. But why? Explain your reasoning. Pause this video and try this out and play once you're ready to move on. I'm gonna type. Yes, this can got it. Yes, is true because if you have two angles that equal 180 degrees, half of 180 is 90 degrees. Even if you divide the supplementary angles in parts, half of each would still equal 180. All right. This video is getting lengthy, but I'm gonna put an example. So let's say that not tight. Okay. let's say that, let's use one of the cards above. We're just going to model what's going on. An angle. And let's say this is 120 degrees and this is brain is not braining, 180, 60 degrees. And let's test out what our explanation is. If we take half, even if you divide the supplementary angles in parts, two supplementary angles is 120 and 60. Why did I say 180 should be 90 degrees? So let's take half of these and see what it's equal to. So half of 120 is 60, half of 60 is 30. Look, we get 90 degrees. So choose any value of supplementary angles and this conjecture will be true. Let's move on. All right, explore number 2. Convince me. There are two intersecting, that's our vocab word, lines that create two pairs of vertical angles. So the intersecting lines is this line and this line. I can't trace. Number 1, what is the relationship between vertical angles? Write down a conjecture. Label the diagram to make it easier to write your conjecture precisely. So you could, actually, let's stay with the same system. You could do it A, B, C, D, E. Label letters at the vertex and at the end of these rays. And what do we notice about the vertical angles? The opposite angles are the same size. So you could say angle ABC is congruent to angle EBD. Don't forget where the angle is at, the letter is there. So B should always be the second letter in this form of angle notation. A much easier, oh wait, forgot. We have to do the other set of vertical angles. So you put two arcs to show that those opposite angles, angle ABE is congruent to angle CBD. A much easier way to do it is if you have only a simple X intersection, A, B, C, D, you could say angle A is congruent to angle B, angle D is congruent to angle C. All right. This notation doesn't always work if you have like multiple angles overlapping, but let's move on. This is a common notation you'll see on the regions. How do you know your conjecture is true? So get your tracing paper and trace everything highlighted. Actually, no. Trace one of the vertical angles, ABE. And if you rotate it around center B with your tracing paper, it'll map exactly onto CBD. You could do the same thing for angle ABC. Only trace one of the vertical angles, rotate around center B until it maps onto EDC. So let's jot this down. If you rotate one of the vertical angles and around center B, it'll map onto the other vertical angle. For example, let's use the orange angles. ABC would map onto EBD. All right, I'm gonna add, stop it. I'm going to add my angle, dang it. Mer. I'm going to add my angle notations in the front, and this video is long enough. You could read the activity synthesis and try the checkpoint. Catch you later.